All right, let's look at the Module 5, Lesson 2 problem set. It starts off by asking you to play this game where you spin this spinner and get a number, and you put the number in the box here. And then you spin this spinner and you get a number, and you put that number in the box here. And then you multiply the two numbers to get their product. And then it says if you get a number as the product that is less than or equal to 8, that's a win. So I just kind of made up some numbers that I feel like would happen if I were to play this. So I'm going to mark everything that's less than or equal to 8 as a win. So win, 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 and win. So out of 15 trials, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 wins. And so if we're talking about this formula up here that I think this lesson is essentially about, it says the probability of an event occurring, which in this case the event would be, really I would say it's more like an outcome. I think they're kind of mixing up the words event and outcome here. But the event, I guess in this case, if they want to use that language, is getting a win. It's getting an 8 or less. And so if we want to estimate the probability of that happening, which I call experimental probability in class, we would take the number of observed occurrences of that event, so the 9 wins I got, and divide by the total number of observations. That's the total number of times I tried, which is 15. So in this case, for me, it's going to be 9/15 is the probability of getting a win, which I think is what they're going to ask here. Yep. All right, so that's essentially what they're asking over here when we turn the page. It says, what is your estimate for the probability of getting a product of 8 or less? So I'm going to take my number of wins as my number of observed occurrences, right? And then I'm going to divide it by the total number of observations, which was 15. You should have a different number here, unless you got exactly 9 wins like I did for your numerator. Your denominator should be 15 if you played 15 games like I did. What is your estimate for the probability of getting a product more than 8? Well, if I played 9, if 9 of them were wins, then the other 6 had to have been losses. So that's 6 out of 15. What is your estimate for the probability of getting exactly 8? I actually need to go back and count that then. I need to figure out how many times did that event occur, or that outcome occur, really is the way I would say it. So let's see here. How many times did I get exactly an 8? 1, 2. I got exactly 8 2 times out of 15. So I would say the probability of that is 2/15. What is the most likely product for this game? So you would go back, look at your results, find the product that came up the most, and then it's just going to be that out of 15. That's going to be your probability for that one. So I'm going to skip forward a little bit. Let's see here. Here, you've got a frequency table. Frequency just means like how many times did something happen. So 9 people from this survey said a dog is their favorite pet. It looks like 5 people said fish is their favorite pet. And if you want to talk about probabilities from this chart graph, I guess I should say, the first thing you want to do is figure out how many people answered the survey, because everything's going to be out of that. If it's snakes, well, that's 5 out of however many people took this thing. So let's look. 9 plus 6 plus 4, so we're up to 19, plus 5, that's 24, plus another 5, that's 29, plus 2. Pretty sure it's 31, unless I messed that up. I don't know. Wouldn't surprise me. So it looks like 31 people answered the survey. And then the probabilities are just going to be whatever the outcome you're considering is, like which pet, divided by 31. All right, let's move on. It says, a 7th grade student surveyed 25 students at her school. She asked them how many hours a week they spend playing a sport or game outdoors. The results are listed below. So 3 people said they play outside, I guess 0. So that would be a frequency of 3. 4 people said they play 1 hour, so that's a frequency of 4. Right, so these numbers over here just count the tallies for you, essentially. Draw a plot of the results. To be honest, I don't know exactly what type of plot they want. Really, anything you do here would probably be okay. Like, if it were me, if this was my homework, I was going to do it, I'd probably just make a bar graph that looks like this one over here, right? I mean, it's a frequency. I actually, you know what, now I think about it, I think people sometimes call these frequency plots because they have frequency on the y-axis. So that's what I would do, is just make it look like that. So it looks like your highest frequency is 7. So, I don't know, maybe make a y-axis over here. Label it 1, 2, 3, 4, 5, 6, 7. And then, okay, so 0 hours, that had a frequency of 3. So let's just draw our bar up to 3. I think you can finish it from there. That seems pretty simple from there. And then when you're trying to estimate the probabilities for these things, for these responses or these outcomes from the surveys, it's exactly like the pet thing. You take whatever the number of responses or the number of outcomes for fish or snake or turtle and divide it by the total number of people surveyed. It'll be the same thing here. The total number of people surveyed in this case was 25. So what is your estimate for the probability that a student answering 3 hours? Well, let's see here, 7 people answered 3 hours. So that's 7 out of the 25 people who answered. All right, hopefully that's not too tough. And then the last thing over here, it says a student played a game using one of the spinners below. The table shows the results of 15 spins. Which spinner did the student use? Give a reason for your answer. All right, so we could figure out which one of these spinners the student used based on this data. Because this one here, all 3 spaces are the same size. So if they use this one, I'd be looking for the data to have approximately the same number of 1s, 2s, and 3s. This one here, the 1 space and the 2 space are considerably bigger than the 3 space. So if they use this spinner, then their data should have more 1s and more 2s and not as many 3s. And then this one has a big old 3 area and a small 1 and a 2. So if they use this spinner, then the data would just have a bunch of 3s. So this is the spin number here, and this is like what number came up when they spun. So that would be the outcome of each trial. Each spin is a trial. Each result is an outcome. So let's see here. How many 1s do we have? Let's see, I'll label it. So 1 came up 1, 2, 3, 4, 5, 6 times. And then 2 came up 1, 2, 3, 4, 5, 6 times. And 3 came up 1, 2, 3. Only 3 times. So 3 came up half as many times as 1 and 2. And that kind of, to me, goes along with this spinner where the 1 and 2 sides, pieces or whatever, look about twice as big as the 3 portion. Did it necessarily have to come from that spinner? No. You could have got this data from this spinner, and it wouldn't be very likely, but you could have got this data from this spinner. But if we're being realistic, most likely this data came from spinner B. All right.